Hello, I am Sarah Ord, and I will be discussing the relationship between displacement, velocity, and acceleration. I'm going to start off with a little situation to get you to better understand velocity, acceleration, and displacement. So imagine I'm Sarah, and I'm sitting in my home, and I hear the ice cream truck going by. And I really want to get ice cream, so I run up and run 10 meters towards the ice cream truck in 5 seconds. I get very close and speeds up a little bit more for about a second, except I miss the ice cream truck and I walk back home in 21 seconds. So there is a lot going on in this situation. And when we discuss terms like velocity and acceleration, it will be easier for you to understand the movement of objects and ways you can explain the movement of objects. So here are some terms that we will be exploring. So the first term is displacement. Displacement is the distance the object has moved from the origin over a period of time. It is usually measured in meters. So when going back to that situation, the origin would be my house, and displacement would be how far I walked or how far I ran to the ice cream truck. That would be the displacement. And displacement is usually explained or shown in the function st, which is just how far the object has moved in meters. Now the next term is velocity. So velocity is the rate of change of displacement of an object with respect to time. Velocity may seem like the exact same thing as speed, but velocity is a vector, which means it has magnitude and direction, which means that where speed just has magnitude. So in terms of velocity, the actual way an object is moving, so if it's moving in the positive and negative direction, will determine the sign of velocity. So the equation we use to show velocity is vt, which is just the first derivative of st. And we know this because in other lessons we've learned that the first derivative helps us figure out the rate of change, or the instantaneous rate of change of a function. So velocity is that instantaneous rate of change that we are trying to find, and is usually measured in meters per second, so how far the object has moved and in how many seconds, so how fast did the object move. The last term we will be discussing is acceleration. Acceleration is the rate of change of velocity. So in terms that I better like to explain it is just the speed of speed. So when we were talking about the ice cream situation, there was a point where I would speed up to try and catch the ice cream truck. Acceleration would be how fast I sped up. So if I was moving at 5 meters per second, but I really wanted to catch the ice cream truck, I would have to run at a faster speed. So acceleration would be how fast I change speeds. So the equation of acceleration would be the derivative of velocity, or the second derivative of displacement, since acceleration is the rate of change of velocity. It is measured in meters per second squared. To better understand the relationship between these, I have some graphs here to explain. So the first graph we have is a position versus time graph. And as you notice that the object would have moved backwards a little bit and then moved forward into the positive direction. And now we have the velocity versus time graph, which shows a straight line as velocity increases. And you may not exactly see the relationship first, but if you were to find the slope of the tangents at different points on the graph, you would notice that they are getting steeper. So the speed of the object is getting faster. And even if you just look at the curve, you would notice that it does get steeper. So the speed or velocity of the object is getting faster. And that is why in this graph the velocity is increasing at a constant rate. Also, you may notice that this does look like a quadratic function, so the derivative of that would be a linear function. Now we go on to the acceleration versus time graph. Since velocity is increasing at a constant rate of change, that means the acceleration is just a straight constant line because the speed is increasing, but it's increasing at a constant rate. And the derivative of a linear function is just a constant function, which is why it is a straight line. Here are some things that will help you answer any questions, and we'll be using kind of these concepts in our examples. So the first thing to remember is that if velocity is smaller than 0, so it is negative, that means the object is moving in a negative direction because velocity is a vector. So if it is negative, then that means the object is moving in the opposite direction. So in my ice cream truck example, when I walked home, my velocity would have been negative because I was moving in the negative direction. If velocity is greater than 0, that means the object is moving in the positive direction. So if my velocity running to the ice cream truck was 5 meters per second, that would be positive because I'm moving in the positive direction. If velocity is equal to 0, that means the object is stationary, so the object has stopped. So when I ran to the ice cream truck and I realized I'm never going to catch it, I probably would have stopped in a little sadness. My velocity would have been 0 because I would have stopped moving. I have no speed. If acceleration is negative, then that means the object's velocity is decreasing. So when I realized I couldn't catch it, I probably would have slowed down. So my acceleration would have been negative because my speed is decreasing. If my acceleration is positive, then that means my velocity is increasing because my speed is getting faster and faster. It is increasing. If acceleration is 0, it pretty much just means that the object is at constant speed. I am in a car and I'm driving at 25 kilometers per hour and I'm just driving at a constant speed. There is no acceleration. I'm not speeding up or slowing down. I'm just driving at a constant speed, which means there is no acceleration. When an object is speeding up, when velocity and acceleration are the same sign. So if I was running to the ice cream truck and I started to get faster and faster, my velocity and acceleration would both be positive because I was running in the positive direction towards the ice cream truck, and I was also speeding up and trying to catch it. An object is slowing down when acceleration and velocity are opposite signs. So if you are driving and the lights were turning yellow, you would have to slow down. So the car would be slowing down, but it is still moving in the positive direction. It is slowing down, so velocity is positive since it is moving in a positive direction. Except acceleration would be negative because speed is decreasing. So in that sense, the object is slowing down when acceleration and velocity are opposite signs. A question. So, Pete is doing a calculus assignment. He determined that the displacement equation for his movement is sx negative x squared plus 4x. What is his average velocity between 2 and 4 seconds? What is his instantaneous velocity at 2 seconds, and what does this mean? What is the acceleration when he returns to the origin? Okay, let's begin. Okay, so it gives us the equation Sx equals negative x squared plus 4x. And it asks us what his average velocity is between 2 and 4 seconds. Now the average velocity is just displacement divided by time. So how fast did he move between 2 and 4 seconds? So with that we have our first question. So the average velocity is just the distance, the displacement, so the difference between where he ended up and where he began at 2 seconds, divided by how much time that was. Okay, so we're going to have s at 4 minus s at 2 divided by 4 minus 2. Now if we put 4 into the equation, it will give us 0, because 4 to the power of 2 is negative 16, is 16 times negative 1, which is negative 16, plus 4 times 4 is 16, which ends up equaling 0. If you put 2 into the equation, that would be 2 to the power of 2, which is 4, times negative 1, which makes it negative 4, plus 8, because 4 times 2 is 8. So that will be minus 4 over 2. So the average velocity is just going to be negative 2, because negative 4 divided by 2 is negative 2. So the average velocity between 2 and 4 seconds is negative 2 meters per second. Okay, for the second question, it asks for the instantaneous velocity at 2 seconds, and what does it mean? So to find the instantaneous velocity, we need to find the first derivative of sx, which will give us the equation for velocity. So we have our equation sx equals negative x squared plus 4 plus 4x. Now we're going to find the first derivative of that. So 2 times negative 1 is negative 2x, and then 2 minus 1 is just 2, and then 1 times 4 is 4, which makes it 4, and then 1 minus 1 is 0, so it's just plus 4. So it asks us for the instantaneous velocity at 2 seconds. So we're looking for, so we're going to substitute 2 into this equation. So -2 times 2 plus 4. And so -2 times 2 is -4. -4 plus 4 is 0. So it asks for, what does this mean? So if velocity is 0 at 2 seconds, that just means that the object is not moving. So this question is asking for the second derivative of this function when it returns to the origin. So when it returns to its original place. So we just need to find where this is equal to 0 first before we can do anything. So we just need to factor this. So make that equal to 0. So then we start to factor. We can right away factor out an x. So we can factor it in -x, which makes it -4. So our friend Pete will be back at his place when he is at 0, so when x is 0, and at 4 seconds, because since we factored out, we know that. So now let's find the second derivative. So we knew that our first derivative is -2x plus 4. So to find the second derivative, all we have to do is just follow the same steps on finding a derivative. So we have s, and we're trying to find the second derivative. So 1 times -2 is -2, and then 1 minus 1 is 0, and there we have it. That is the acceleration function, and it asks for the acceleration when he returns to the origin. So no matter where he is on the function, his acceleration will be -2 meters per second square. For our second example, we have a graph here shown. The graph below, the graph on the side, shows the movement of a car. Determine when the car is driving in the positive direction, when the car is driving with constant speed, and when the car would have hit a red light. So I don't need to write anything out for this, but if you look at this graph, we're trying to determine is driving in the positive direction. So if we determine that, especially in this, since there is no negatives, the positive direction would be moving upwards, so moving further away from the origin. So the car is moving in a positive direction when x is greater than 0 but smaller than 6, because the distance is getting further away from the origin. When is the car driving with constant speed? For constant speed, the slope of the tangents would have to be equal along the whole area. So when you look at this graph, where would that happen? It wouldn't happen here, because if you were to find the slope of the tangents, so the velocity, the instantaneous velocity at those seconds, they would be different. So it is the same answer as the first question. So when x is greater than 0 but smaller than 6, because if we were to figure out the derivative just of this area, you would realize that it would just be a straight line, because that is a linear equation, so the derivative would be a constant function. When would the car have hit a red light? So the car would have hit a red light at around 6 seconds. It would have driven up and stopped. Maybe not the best driver, probably didn't slow down, but the driver stops, and for a couple of from between 6 and 11 seconds, the car is not moving, the distance has not changed, so the car would have hit a red light. Okay, so for our third and last example, we have a particle, and this particle is moving along the x-axis of a function. Its movement is represented by the function st equals 1/3 t to the power of 3 minus 8t squared plus 4t. What is the velocity when acceleration is 0? So the function it gives us is st is equal to 1/3 t to the power of 3 minus 8t squared plus 4t. What is the velocity when acceleration is 0? So to find when acceleration is 0, we need to find the equation for acceleration before we can do anything else. And that is just the second derivative of this function. So the first thing we're going to find is the first derivative. The first derivative will give us the equation of velocity. So let us find the first derivative, and then we'll find the derivative. Then we'll find the equation for acceleration. So 3 times 1/3 is just 1. 3 minus 1 is 2, so that's t squared. And then 2 times -8 is -16. And then 2 minus 1 is just 1. And then that is plus 4. Now that is our equation for velocity, which we will need in a second, but the question asks when acceleration is 0, and for that we need to find the acceleration function. So we just need to find the second derivative of that. So we're going to now find the second derivative. So 2 times 1 is just 2. 2 minus 1 is just 1. That's 2t. And that's minus 16. So the question asks what is the velocity when acceleration is 0? So we just need to find when acceleration is 0. Okay, so that is our acceleration. So we need to find when this is equal to 0. So we're just going to make that equal 0. So that is 2t minus 16. Now we're going to try and isolate the t, so bring that over. So that's 16 equals 2t And then we're going to divide both sides by 2, which leaves 8 equals t. Okay, so it asks, what is the velocity when acceleration is 0? So now we know that at 8 seconds, so at 8 seconds, the acceleration, I'm just going to use at 8 seconds, acceleration is 0. So now we need to find what the velocity is at 8 seconds. Okay, so if we know that at 8 seconds acceleration will be 0, we just need to substitute 8 into the velocity equation. So that's s, the second derivative, I am just going to rewrite that in terms of velocity just so you recognize that. So our st is just our velocity. So that is t squared minus 16t plus 4. So we are going to place 8 into our velocity function. So v at 8 seconds. So that is 8 to the power of 2 minus 16 times 8 plus 4. So that is 64, because 8 to the power of 2 is 64, minus 16 times 8 is 128, and since it's negative, so it's minus 128, and then plus 4. So that all equals negative 60. Okay, and so we are just going to write our statement. So our little velocity is negative 60 meters per second when acceleration is 0. I just wanted to explain and give you a graphical understanding of what we just solved. So the question asked what is the velocity when acceleration is 0? So I have the 3 functions we have and what we found. So the purple is the displacement function, so the original function. The green is our velocity function, and the orange is our acceleration. So the question asks, what is the velocity when acceleration is 0? So as you look at the orange, acceleration is 0 at 8. So we just found what the velocity is at 8 seconds. So if you go down to 8 seconds on our green function, our velocity function, you will see that it is -60. So the velocity when acceleration is 0 is -60 meters per second. Thank you for watching, and I hope you learned a little bit about velocity and acceleration and displacement and the relationship between them, and also how you can use derivatives to answer questions. Thank you.